Welcome to another episode of Solar Pulse. I am your host Kuda, and today we are going to be talking about inverters. Inverters have evolved over time. Now you have what is called hybrid inverters. Away from the traditional ones we used to know, hybrid is an integration of an MPPT within that particular inverter, whereas the traditional you used to need an inverter on its own, an MPPT charge controller on its own, and other components that you need to set up your solar system. But this is a game changer because it shortens the process of doing the work. At the same time, it has become cost effective to have one unit with integration of all these components together in one, and they've gained momentum and popularity in the market. So I just thought today we should discuss the difference or the benefits of hybrid inverters. And also they are now coming in different voltages. Now you have your high voltage inverter and a low voltage inverter, which means they can go with different applications. So it really depends where you want to apply it, and you can consider some of these. And you realize, advantage of hybrid is, has become affordability, low cost of buying a single unit, easy to install because all components are in one unit, and also they give a good finish once the setup is completed. But on the same time, the downside is when there's a breakdown with this particular system, it means the entire unit is down and you need to get it replaced, vis-a-vis if it was the traditional setup where you have your inverter, your MPPT. If your MPPT breaks down, you can quickly take it out of the equation and still continue to have your inverter powering your loads whilst you get that resolved. And there are more options now in terms of the voltages of the inverter, which allows certain advantages, especially if you are going to go high voltage against low voltage. And with high voltage, we are talking in terms of solar panel configuration. You can have a 48 volt inverter, but with a high voltage configuration on the solar array. You can have a 3 kVA inverter with a high voltage configuration on the solar array, which then allows your equipment to charge your batteries fairly quicker, to generate power more efficiently, and reduces the losses from your solar system. So these are some of the advantages that you get from putting up a high voltage inverter. So the range of a high voltage inverter is between 120 to 450 VDC. In some cases it can even reach 800 VDC. And on the low voltage you are talking of 60 to 145 VDC. In some cases it can even reach 250 VDC. So you realize we are talking of solar panel configuration on this platform. So what it basically means, where you have high voltage, in most cases it's low current. So in this case, the setup we have maybe 18 to 27 amps. Then this setup, in most cases, you have maybe 60 to even 100 amps in terms of current. Basically what it means is, in this scenario, when you're dealing with high voltage inverter, the configuration of your panel is series. All the panels to the required voltage. In most cases, you can't para series, especially if you have a low current. In this case, most of the panels are coming maybe at 14 amps. So if a panel is 14 amps, if you are going to para series, it means this current is going to increase most probably 28, and our current is way lower. So whatever setup or configuration you need to do is designed between these two options. You have more options if you want high voltage, or if you can do with low voltage, and if you want high current. So it depends really on the application where you want to set it up. Because in this case, you have low voltage, but you have a higher current. So in this case, you can actually do a series, maybe 3 in series, and then you convert it to parallel. So even if your current increase, it will still fall within the threshold of your setup. So those are some of the variables when it comes to designing a system with high voltage or with low voltage. And you realize in most cases nowadays you can get your low voltage systems in the range of maybe 1 to 3 kilowatt, and you get from between 5 kilowatt upwards. The MPPT then can allow high voltage on the solar array. So one of the key advantage of the high voltage in this case is maybe when you have your lithium battery, you want your batteries to charge fairly quicker. You'd rather have a high voltage setup than having a low voltage setup. And with a high voltage setup, even if there is fluctuation in terms of power as the day goes down, you realize the voltage will still be fairly higher, allowing better charging of your batteries. Unlike with a low voltage, if the sun is going down, the voltage is going to be way lower, maybe to be generating any power that is significant in order to charge your batteries. So these are some of the dynamics that needs to be considered as you consider which particular voltage do you want to go with. But at the same time, high voltage can be fairly scary because of safety issues. Let's say all your panels are connected in series. Someone has a mistake, that power can be very dangerous. So it's important to understand some of these dynamics as you consider setting up. So we've been talking about on the MPPT side and in terms of these voltages and how they work. I want to talk another aspect which can also change on our inverter system, which is called the high voltage battery configuration. So there are batteries which come configured for high voltage. So those ones would then have to go with a high voltage inverter. So the inverter will have a high voltage MPPT and we have a configuration on the battery side which is also high voltage. So the range can be from 100 to 1000 volts, and in most cases the applications for the high voltage is maybe industry, is agriculture, where you need high power and you're running motors. So if you want them to run efficiently, you can run them on the high voltage setup. But compatibility on the majority of the inverter with a high voltage MPPT, we have maybe a 12 volts, 24, 36, or 48 volts in terms of battery configuration. So depending on the application and where you want to use this, you have to consider which inverter and which voltage range do you have to go in that capacity. So in this case, we talk of 12 volts is basically small systems and small applications. In this case, you're talking of, you want to power lights, you want to power maybe a laptop, nothing too heavy, it will work with the 12 volts. But you realize the more load you put in there, like you want to put in a fridge, it becomes unstable and the power becomes erratic. Sometimes maybe it cuts off, during usage. So from there you move on to a 24 volt or a 36 volt system. Though 36 volts are not very common, in most cases 24 volts, where you have maybe 2 gel batteries which are in series to produce 24, and nowadays you now have a lithium battery which comes as 24 volts, and this then becomes for moderate power needs. A small household, you just want to power up your lights, your TV, maybe a single fridge, then you can consider a 24 volts. Now, if you want to go bigger, maybe you've got now a bigger home which requires a lot of power. You have a couple of fridges running, you have a couple of TVs running, you have microwaves running, you have a water pump running, and all those kind of things. Then you need to also then consider a 48 volt system. This is now a much more stable unit, which is then used at residential entry point as well as commercial usage. But beyond that, you have that high voltage we were talking about. This is massive industrial equipment which require power. Then you need to go high voltage on the battery to make sure it's configured in such a way the battery lasts longer, even if it's getting draw power from these big systems. So basically, this is what you need to know about the the battery configuration within your inverter. And as you are deciding and designing a system, these are some of the information that then becomes very important to be aware of. So the pros and cons of a high voltage system. So high voltage reduces wiring. There's not so many wiring that you need when you're setting up a high voltage. If you're setting up on the solar array, you're just doing a series of all your connections on the solar array. Then you run two cables that are going into the house or into the combiner box, then straight into the inverter MPPT. That's how simple it is. But if you are doing a low voltage, it requires then, you are either doing a series, then you parallel, so it requires a lot of cables in some cases, which is not necessary. Improved efficiency. So if we've spoken of efficiency, the performance of a high voltage system is way better, even in cloud covers, than a low voltage system. Because as long as the voltage is low, let's say you have set up your system and it's ranging around 60 to 40 to 145. So if it's too cloudy, you notice most probably it will go to 60 volts. And worst case scenario, if it goes under 60 volts, it means there's no generation coming from your system. But if it's high voltage and you have put sufficient solar panels, if it drops, in some cases it may not go beyond the 120, which means it continues to generate even during the lowest environments that you would be experiencing. So that's better efficient. Then scalability. For if you want to scale a system, it's easier to scale on a high voltage for large application, or if you want to maybe to grow your system at a household level, 10 kilowatt, 15, 20. So most of these inverters have got a parallel connection, which you can make use of. You can actually put 5 or 6 units, and which means where you have been generating a 5 kilowatt, you now generate 25 or 30 kilowatt of power, and you power all your loads, considering going off grid. And high voltage is for high power outputs. If you want stable power, which doesn't cut off, which maintains the output, that's a very good investment to consider. Then direct power usage for solar. So basically, this is where now, with high voltage, you can literally use your solar array during the day without the battery. So the configuration, even on the inverters, allows you to even switch off the batteries and still get solar to power your loads during the day. That will work perfectly fine. So it's important to, as you are considering, this is a very good option. Whereas with a low voltage, if you remove the battery component from your system, the system then will begin to act up and it won't be able to work. But with high voltage, most of the inverters, they work without a battery switched on. So that is a very good advantage to consider. But at the same time, the cons now, it requires high initial cost, which means you need to be ready to make a big investment. And there's also issues to do with safety concerns, because it's high voltage. It needs to be done correctly and properly to avoid any harm. Also complexity of setting up, those are some of the things, the cons for high voltage. But it has gained so much momentum and in the market, especially because of the cost aspect. Then the low voltage, obviously, is cost effective, getting an inverter, simple design and installation, low safety risk. But then you have a challenge for scalability. It has limitations in scaling the system. It's less efficient for long distance. For example, if the cables are running longer, there's a lot of power losses that can happen. So you'd rather stick with a high voltage in this case to be able to have a better functioning unit. So from us at Solar Pulse, this is something that we thought it's important to learn about the inverters, how they work, and this helps in designing your system. As you are designing the system, you want then to consider, should I consider high voltage or low voltage system? Because of some of these various advantages and disadvantages that you can experience with the system. Thank you very much.